What is a laboratory apparatus? Laboratory apparatus are the tools required to complete lab work, including test tubes, pipettes, beakers, and graduated cylinders. These are the most common utensils and appliances that you need while performing hands-on activities in a laboratory. Some of the most common kinds of laboratory equipment can magnify, measure, ignite, weigh or hold various substances for a variety of purpose. Here are some examples of laboratory apparatus that can be seen in a laboratory.
These are graduated cylinders, and no, they didn't graduate from high school. The graduations are the lines that are on each one. The lines tell you how much is in the container, and these measure in milliliters. The more lines that you have, the more exact the measurement. So the more lines, the better the equipment is to measure out something that you need for a lab. It would be better to measure out 35 milliliters with a graduated cylinder than it would be with a beaker, because there are more lines on the graduated cylinder. Okay, next are funnels. Funnels can come in long stem. Funnels can come in short stem. Long stem, short stem. Funnels. We use funnels to funnel liquids from a larger container into a smaller container, and oftentimes we will use filter paper. The filter paper we'll fold up and put inside the funnel, and then pour the liquid through the funnel and have a clear liquid. Okay, everybody knows what a test tube is. Test tube are those iconic things that you would see in a chemistry lab, and they come in all sorts of different shapes and sizes. They have an open end, they have a closed end, but they all look like test tubes. Now, what do you think this thing is that we are holding the test tubes in? That's right, it's a test tube holder. It holds the medium-sized test tubes, it holds the little-sized test tubes, and even though it may not hold those, we can still stand them up and let them dry. That is a test tube rack. Okay, so we have the test tube rack, we have the test tubes, now we have a test tube clamp. Test tube clamp will clamp around there. We actually are not squeezing to clamp it on there, it's spring-loaded. So when you squeeze it, you release it. Squeeze, release, and you have it. And so that way your hands are free to move around, and you can hold this in the Bunsen burner fire or do whatever you need to.
All right, be very, very quiet. We're hunting the most dangerous animal in the entire chemistry lab. It's the dun-dun-dun Bunsen burner. I'm ready for lab. I have my safety goggles, and I have my lab coat on. It's time to use the Bunsen burner. This is a little guy that you're going to get very familiar with. Along with the Bunsen burner, we're going to use some other equipment. First of all, it's the ring stand. It's simply a stand with, ta-da, a ring. The ring stand will be used over the Bunsen burner. You can use wire gauze. Wire gauze has a heat-resistant material here in the center. When we put it on the ring, now we can set flat-bottom things like beakers and Erlenmeyer flasks on the wire gauze. What if what you're going to use on the ring stand doesn't have a flat bottom? Okay, I can stop now. Use the pipe stem triangle. We'll put the pipe stem triangle up there, and then we can take something with a rounded bottom, something like a crucible, and it will sit inside the pipe stem triangle just like that. Now, when it's time to get the crucible off of the heat, we can't just reach up there and go, "Ow!" No, we'll use crucible tongs. Crucible tongs, a crucible, and a crucible lid.
These are evaporating dishes. What do you do with an evaporating dish? Well, you evaporate. What we'll do is we'll put a solution in here that has something dissolved in it. We'll put it up over the Bunsen burner, and then when we heat it up, the liquid evaporates, and what we're left with is the substance we want. So these are evaporating dishes. These things are used to crush up large crystals into smaller powder form. They're called mortar and pestle. Here's the mortar, here's the pestle. I've got two different sizes to show you. These you would usually see being used in a drugstore that mixes its own medications and pharmaceuticals. A mortar and pestle. This is a microplate, sometimes called a spot plate. If you don't have a whole lot of the liquid to react in the chemical reaction, you don't want to use a test tube, you can use a spot plate. A spot plate has things called wells. These are little depressions where you could put some liquid and just drop it in. And you would probably use something like this, a little disposable pipette. It has a little squeeze bulb so that you can draw the liquid up, and then you'd put a few drops in that one, and then you would get another pipette with a different chemical and put it in there in the same well and see if there's a reaction. So we have pipettes, and we also have a spot plate. Okay, you probably recognize these. They're beakers. They're not jars, they're not bottles, they're not flasks, they're beakers. Beakers can come in lots of different sizes, and we measure the volume of the liquid inside in milliliters. So when Mr. Womack says go get a 400 ml beaker, he means this beaker right here that holds up to 400 milliliters, 400 ml beaker. We have them in 1,000 ml, 600, 400, 250, 150, 150 ml beakers. These are called Erlenmeyer flasks. They're a little different from the beakers in that they do have a triangular shape. They still will measure general amounts of liquid. We still wouldn't want to use them for an exact amount, but you could measure an approximate amount with these graduations.
Okay, you know Mr. Womack doesn't smoke, not unless his hair is on fire. So, in order for us to light the Bunsen burners, I'm not going to pull out my handy dandy Zippo. So what do I use? A striker. I'll use the striker over the Bunsen burner and light the Bunsen burner.
Okay, here we have volumetric flasks. These are used to make solutions. We don't use them to measure in. We don't use them to heat things in. All we do are use them to make solutions. They only have one gradation, one line on them, and like for example this one says a 250 milliliter volumetric flask. Well, we would use this one to make exactly 250 milliliters of a solution by measuring out the right amount of a solid in there and then dissolve it in water and add the water up to that line, and it would make exactly the concentration of solution that you want. Again, these are volumetric flasks. This is a Florence flask. It looks like a volumetric flask, but it has one very important difference. This one can't stand up on its own because it has a completely round bottom. Looky there. If I tried to stand it up, no, wouldn't do it. This is also called a boiling flask. You would have to clamp this into some sort of equipment to hold it upright over a heat source. You can't heat a volumetric flask, but you can heat one of these. So this is a Florence flask, also called boiling flask. Okay, let's look at some of the smaller equipment that's on your list. What you see in front of you are called stoppers. There are two kinds of stoppers. There are rubber stoppers and there are cork stoppers. A watch glass. A watch glass is simply a piece of glass that has a kind of a curved back. I think you can see that. And we use that for a number of different things. First of all, we'll lay things in there, but we also will put this on top of an evaporating dish, and the things that are evaporating will collect on the underside of the watch glass. So that is a watch glass. So we use this probably the most out of all the glassware. What is it? It's a glass stirring rod. We use it to stir. We can't use metal in a lot of the things we stir because the metal will react. So we use glass, which doesn't react. These are called forceps. In the chemistry lab, we use these, aka tweezers. I'll go along with the fact they look like tweezers, they sound like tweezers, they operate like tweezers, but they are forceps. This, ladies and gentlemen, is a hot plate. No, we don't use it to cook grilled cheese. We use it to heat chemicals. It simply has a little dial.
You turn it on, light comes on, and you heat the chemicals. And what should you remember when the light is on? Don't touch the surface. Ow! What we have here, folks, is a triple beam balance. And we call it a triple beam because there are 1, 2, 3 beams. And we'll take the mass of different chemicals with a triple beam balance. More often than not, however, we'll be using, ta-da, the quad beam balance. Why do we call it a quad beam balance? Because we have boom, 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 4 beams, quad beam balance. This one is a little bit more exact than the triple beam balance, and so we'll be using this quite a lot in the chemistry lab. When we're not using the triple beam or the quad beam balance, what we'll be using is the handy dandy electric scale, which also measures to the nearest 100th of a gram. The two instruments you see here are a scupula, has a curved shape, and a micro spatula. The micro spatula is used for measuring out small amounts of material. The three things that you see here are a striker, a dropper, and a ceramic square. Very long tubes with the valves at the end are called burettes. They measure up to 50 milliliters of liquid. The clamp that they sit in is called a double burette clamp. This is a gas collection tube. It's similar to a burette, but it does not have the valve on it. The apparatus you see here is called a pneumatic trough. The pneumatic trough gets filled with water. There is a gas collection bottle or a wide mouth bottle, a glass plate that is used with the bottle, and there's usually also a hose and some bent glass tubing. These are things that you might use for a gas-producing lab experiment. Ring stands don't always just hold rings. Sometimes they hold test tube clamps. These will hold a test tube over something hot so it can be heated without you burning your hand.
Common laboratory apparatus. Graduated cylinder. Marked with milliliter scale and is used to measure volume. Erlenmeyer flask. Container. Common sizes are 125 milliliters, 250 milliliters, 500 milliliters, may be heated. It has a thin neck and a wide base, used to hold liquids when carrying out reactions and preparing solutions. Beaker. Glass container. Most are Pyrex. Common sizes are 100 milliliters, 25 milliliters, 400 milliliters. It can be used as a container, shows approximate volume, and may be heated. Test tube. Glassware that comes in many sizes. It has many uses and can be heated. Test tube holder. Made of metal, has a clamp with a spring handle, used to hold a test tube. Test tube rack. May be made of wood, metal, or plastic, used to hold test tubes in an upright position. Stirring rod. Made of glass, used to stir combinations of materials. Mortar and pestle. Heavy porcelain dish with grinder, used to grind chemicals to a powder. Crucibles and cover. Are used in the laboratory to contain chemical compounds when heated to extremely high temperatures. Crucibles are available in several sizes and typically come with a correspondingly sized lid. Funnel. Made of glass or plastic, used to hold a filter paper and can be used in pouring, to avoid spills. Filter paper. A semi-permeable paper barrier placed perpendicular to a liquid or airflow, used to separate fine substances from liquids or air. Watch glass. Curved glass, may be used as a beaker cover or for evaporating very small amounts of liquid. Bunsen burner. A metal heating device connected to a gas outlet with rubber tubing, used to heat chemicals in beakers or test tubes, has adjustable air hole allowing some control of temperature. Iron rings. Iron ring with screw fastener, comes in several sizes, used to fasten to the ring stand as a support for an apparatus. Forceps. Metal or plastic, straight-tipped instrument used to isolate and remove small particles. Thermometer. Made of glass and filled with a red or blue liquid, usually alcohol, used to determine temperature. Spatula. Made of metal, has a flat rounded end and a rectangular end, used to transfer solid chemicals. Rubber stopper. Used to cap the openings of glassware such as test tubes or Erlenmeyer flasks. Reagent bottle. Reagent bottle can be used for storage, for mixing, and for display. Burette. The burette is a graduated glass tube and a stopcock at the bottom, used specially in laboratory procedures for accurate fluid dispensing and measurement. Evaporating dish. The evaporating dish is used to heat and evaporate liquids. Florence flask. It is used for heating substances that need to be heated evenly. The bulb bottom allows the heat to distribute through the liquid more evenly. The Florence flask is mostly used in distillation experiments. Pipe. Pipe is used for moving small amounts of liquid from one container to another. It is usually made of plastic and is disposable. Test tube brushes. The test tube brushes are used to easily clean the inside of a test tube. Tongs. Tongs are used to hold different objects such as flasks, crucibles, and evaporating dishes when they are hot. Clay triangle. Clay triangle is used in the process of heating substances. It is used in conjunction with other laboratory equipment to create stable framework in which to place a substance, usually chemical, while it is heated to a high temperature.
Good morning, class.
Good morning, Missy.
You may begin with your experiments, but please remember the safety rules and make sure to follow my instructions. Please tie back long hair to avoid any interference with your laboratory work. Also, eating and drinking are prohibited in laboratories, so don't eat inside the lab. Make sure that your clothes don't get in the way and pose a safety risk when conducting experiments. If you break or spill any chemicals or equipment, you must report to me. Don't taste chemicals unless I specifically tell you so. No playing around in the laboratory. Whenever you conduct activities that pose risk of injury to your eyes, always wear safety goggles. Be mindful of where you stand in the laboratory. Do not stand facing apparatus being heated by Bunsen burners. Pay attention. In an emergency, you must be aware of the location and use of first aid and emergency facilities. Looks like we've run out of time for today. Please stop all work, clear and clean up your benches. Daniel, have you washed your hands? You need to wash them thoroughly before leaving the laboratory, regardless of whether you are wearing gloves or not. Thank you, class.
Thank you, Missy.
Laboratory safety measures. Basic safety rules for laboratory conduct should be observed whenever working in a laboratory. Many of the most common safety rules are listed below. 1. No food or drink is allowed in lab, unless food or drinks are provided as a part of the lab. 2. Shoes must be worn in lab. 3. If you have very long hair, please tie it back in the laboratory. 4. Read all precautions in the laboratory manual and on labels, and follow directions exactly. 5. Label all test tubes and other containers with contents. 6. If glassware accidentally becomes broken, carefully clean it up with a broom and dustpan. Dispose of the broken glass in containers labeled for broken glass only. 7. If you are in doubt about directions for an experiment or activity, or about use or disposal of materials, ask first before acting. 8. Do not use your thumb as a stopper. Swirl gently or put a piece of paraffin over the opening to mix solutions. 9. Do not pour reagents and chemicals down the sink. Dispose of these only in designated containers. 10. Do not touch, taste or smell chemicals unless specifically instructed to do so. Laboratory safety signs. All laboratory work must be accomplished with safety in mind. Safety signs are very essential as they aid laboratory workers, and provide complete protection while conducting their work. Labels and warning signs in the proper handling of different chemicals, acids, and other substances must be followed with great care, to ensure safety and to avoid accidents.
So how do you know when chemicals are dangerous? Do you just take a guess? Open the container and smell or taste it? Definitely not. Warning signs are printed on the chemicals to alert us to what kind of properties the chemical has. They tell us about the potential danger if a chemical is used incorrectly. Let's look at some signs that you need to familiarize yourself with when you start working in a laboratory. This means that ingesting the chemical can kill you. Chemicals like hydrogen cyanide and heavy metals like mercury usually have this symbol. This is the oxidant sign. Chemicals like potassium permanganate or phosphorus often have this sign. This means the chemical is harmful or an irritant. These won't kill you, but can irritate the skin or eyes. This is the explosive sign, and would include TNT, gunpowder, or hydrogen gas. You've probably seen this before on gas tanks. It means the chemical is flammable. Flammable chemicals include ethanol, methane gas, and petroleum. Finally, there are corrosive substances. These are usually acids like sulfuric acid and hydrochloric acid. These tend to burn or corrode surfaces, including skin and hard surfaces. So now you know to look out for these warning signs. Why not ask your teacher if you can look around the laboratory and spot these signs? Now you know what they mean. Let's look at them one more time. There's toxic or poison, oxidant, irritant or harmful, explosive, flammable, and corrosive. There are more signs that people use, but these are the ones you will find in your school laboratory. So keep a lookout and don't get too close.
Safety guidelines for handling accidents related to chemicals. In the situation of chemical spills, inform a teacher or laboratory staff immediately. Cleanup of chemicals should only be done by knowledgeable and experienced teachers or laboratory staff. Spill kits with instructions, absorbents, reactants, and protective equipment should be available to clean up minor spills. Solid sodium hydrogen carbonate may be used to contain acid spills. Flush the affected and exposed area with running water from the tap or safety shower for at least 15 minutes. Remove contaminated clothing. Flush the eyes with running water using the eye washers in the laboratory for a minimum of 15 minutes. Eyelids have to be forcibly opened to ensure that the water or eye solution goes behind the eyelids. Remove contact lenses as soon as possible in order to rinse off any harmful chemical from the eyes. Call for an ambulance by dialing 995. Spit the chemical out if it is still in the mouth and wash the mouth with plenty of water. Induce vomiting by stimulating the back of the throat with the tip of a finger. Seek medical attention immediately. Remove clothes and shoes if necessary when burnt by contact with chemicals. Use water for treating chemical burns. Wash the injured area with running water for at least 15 minutes. This can prevent further damage to the burnt tissues. Minor burns are best treated by soaking the affected area in cold water. Do not apply burn ointments or spray to affected areas. Cover with sterile or dry and clean material. For large affected areas, seek medical attention immediately.
The skull and crossbones symbol, consisting of a human skull and two bones crossed together behind the skull, means the product is poisonous. Whereas most chemicals are fairly dangerous if ingested and inhaled, many of these are dangerous even in contact. The flame symbol means that a substance is flammable or extremely flammable. Chemicals are to be stored in flame-resistant cupboards. Volatile solvents can be a particular problem, as they are prone to spread around from unsealed containers. This also covers pyrophoric materials, or materials that catch fire spontaneously on exposure to air. The symbol which shows a chemical poured onto a material and a hand means a substance is corrosive. You have to avoid contact with the skin. Bear in mind that these can, under some circumstances, rust chemical cupboards. The symbol for oxidizing chemical is flame over a circle. Oxidizing chemicals are materials that spontaneously release oxygen at room temperature with slight heating, or promote combustion. They are to be kept away from flammable chemicals at all costs. Modern hazard safety signs. Due to the advancement of science and technology, several types of hazards are found in today's modern laboratories. To warn against danger that might be present in laboratories and workspaces, modern hazard signs for laser, radiation, chemical weapons, or biohazards are used. These symbols are often regulated by law, and directed by a standard organization. That is why they appear with different colors, backgrounds, borders, and additional information such as the type of hazard. Some of the important modern hazard signs in laboratories include the following. 1. Biohazard safety sign is used to warn people against biological hazards, including the presence of biological materials. This symbol is used for labeling biological substances that carry significant health risks, including viral samples and used hypodermic needles. 2. Laser safety sign indicates the presence of a laser system in the laboratory or workspace. This serves as a safety caution, since even low-power lasers can be hazardous, especially to human eyesight. Posting signage in laser areas is important for safety. 3. Ionizing radiation safety sign cautions people against the potential dangers of being close to a large source of ionizing radiation. Until recently, the traditional trefoil symbol was used as the radiation hazard symbol. The new safety sign also shows it at the top along with skull and crossbones. Activity. Directions. Answer the following questions. 1. What pieces of apparatus are used for measuring? A. Temperature. B. Small amount or volume of liquids. C. Large amount or volume of liquids. D. Mass of substance. 2. Suggest ways on how to store and handle properly the different glasswares to avoid accidents in the laboratory. You can use illustrations to show your idea. 3. Why is that most of the containers of substances and those used for heating are made up of glass rather than metal? 4. Explain why the thermometer should not be shaken rigorously to lower the reading to 0 before using it.
To summarize our lesson for today, science is the knowledge gained from observations and experiments to describe and explain the world around us. Science may be classified into social science and natural science. Natural science can be further divided into pure or applied science. A scientist is someone who studies science. Some of the famous scientists we have are Albert Einstein, Newton, and Aristotle. Scientists use tools in order for them to conduct their research. These are called laboratory tools or equipment. Some of the laboratory tools commonly used by scientists are beaker, test tube, graduated cylinder, funnel, and thermometer.
Task. Directions. State the importance of science and technology in our daily lives. You are free to choose among the following options. A. Poster. B. Video presentation maximum of 5 minutes. C. Poem. D. Song. E. Acrostic poem.
I hope you all learned a lot from our lesson for today and see you on our next Science 7 class.